Concepts surrounding why you would choose the chain of responsibility pattern are that you want to decouple the sender and receiver objects. Oftentimes in an application, we want to pass a request to a receiving object without knowing who the sender was, and vice versa. The sender shouldn't have to know who the receiver was in order for it to process that request. When using the chain, the receiver should also contain a reference to the next receiver or the successor. This is an important part when choosing and implementing this pattern. It doesn't know the whole hierarchy, but it does know who's next in line. One of the main reasons for choosing this pattern is to promote loose coupling. We can modify the chain and add links to the chain without rewriting large portions of the logic in the application. It should also be okay that there may not be a handler for a given request and the application will just continue on. Examples of this in the Java API are the Java Util Logging Logger API. And although not part of the core Java API, the Servlet API, specifically Servlet Filters, is another great example of chaining. One of the best examples I've seen of this pattern in use, though, is how Spring implements their security chain filter in Spring Security. It's a great example of chaining. The design of the chain of responsibility has a chain of receiver objects. This can be implemented in a number of ways, but some basic form of a list is typically the most common. Each handler is based off of a main interface that defines the contract between each chain link. There is a concrete handler for each receiver or implementation that will interpret a request. In building the chain, each handler has a reference to its successor or the next link in the chain. The pieces of the UML diagram are a handler and a concrete handler, and then its successor. Let's look at that UML diagram now. This is the UML diagram for the chain of responsibility pattern. The client makes calls to a handler class, and that handler is a common interface or contract for all of the handlers and is the abstraction for all links in our chain. There are multiple concrete handlers for each link in our chain, and although not really clear in the UML diagram, but the handler will pass it to the next handler in a chain if it doesn't know how to process that request. This is known as the successor and is one of the key parts of implementing this chain correctly. To help gain familiarity with this pattern, let's go ahead and look at an everyday example of it in action. If you look very far for an example of the chain of responsibility pattern, you will quickly find an example of logging. I didn't really want to use this in the example that we are going to develop together, but do still think it is a great example of this pattern and decided to show it for an everyday example. The various logging methods are passed through a chain, and if there is a handler, it will log. Otherwise, it will pass over it. Let's look at this in some live code now. Here's the code for that everyday example we were talking about using the logger, and you can see it's pretty simple. We create an instance of the logger by just using the get logger based off of a string name, and then inside of our code we begin setting up the chain to handle the logging levels. So we set our logger to a level of finer, and then we create a handler, one of our concrete handlers, to also have a level of finer, and then we add that handler to our original logger. So we start building that chain. Now if we had multiple handlers, we've got one for the console, we could have one to a file or some other syslog or other logging handler, it doesn't matter, there's a lot of various implementations. We could build that chain to go through and build those handlers up. The pieces we have down below here are our actual logging statements that we're going to see what gets printed out. We have finest, finer, and fine, 3 of the 7 or 8 various levels that are available to us as a logger. And you'll notice that we set ours to finer. So our chain ends with finer. Finest ones are going to fall off the end of that request cycle, so nobody's set up to handle that request. So go ahead and run this and see what prints out. You can see that our finer statement and fine statement both printed out, but the finest did not, and that's just because we don't have a handler that's set up to go to that level of logging, so that link of the chain doesn't exist. Let's go ahead and create our own example of this now that's a little bit more complex than just this basic logger example, and process a request throughout our chain. We're going to start off by creating the handler, and then from there build the rest of our chain out. So this exercise is actually based off a real world example that I have in my office that I work with. How great that chain of responsibility pattern can be. We did start to touch on some of the pitfalls or problems with this pattern. Let's go into that a little bit deeper. One of the pitfalls that you run up against is the handling handler guarantee. We aren't guaranteed that someone along the chain will in fact handle our request. This is a direct reflection of our runtime configuration. We have great flexibility with this configuration, but it can mean that there are some configurations that haven't been tested and something might not get processed. There is also a concern about chain length as well. If you just keep tacking on handlers, it can get quite large and the performance could start to degrade. This usually isn't a problem in my experience, but it is something to keep in mind. Let's go ahead and compare this with another pattern though to see when it might be a good idea to choose it or something else. To contrast the chain of responsibility pattern, let's compare it with the command pattern. The chain of responsibility is a pattern that deals with handlers, and each one of those should be unique. They also know about their successor. This is key because the pattern doesn't know about other commands surrounding it. The chain of responsibility will pass it on to its other successor, for it doesn't know what to do with it. The chain can oftentimes also utilize the command pattern in its implementation of those individual concrete handlers. The command pattern is actually quite similar to the chain of responsibility in that its commands are also unique, just like the handlers. It's different though in that it should encapsulate all of its functionality. It doesn't attempt to hand it off to somebody else if it doesn't know what to do with it. Commands are also reversible or trackable in nature. We will often store a history of commands, and we don't do this with the chain of responsibility. In fact, that is a risk, as we mentioned in the pitfalls, that we could have a chain not handle a request at all, and we don't know about it. Although the pattern doesn't enforce this, we usually call a command because we know it will handle it. But the chain, we just send it down the chain, assuming that somebody along the way will handle it. Just recap what we've learned with the chain of responsibility pattern. It decouples the sender and receiver from requests. So the sender doesn't have to know who's going to handle its request, and the receiver doesn't have to know who the sender was necessarily. You can configure this at runtime, and that can be helpful or it can be dangerous as far as your application is concerned. Usually that flexibility is looked upon as a positive thing though. It is hierarchical in nature. In other words, it's going to build as it goes down the chain as to who may be able to handle that request. You do have to be careful with large chains because it can become a performance bottleneck, or it can be confusing where that business logic might be configured inside that chain. The next pattern that we want to look at is the command pattern. And the command pattern shares some of the similarities as we mentioned in the contrast section of this course.